In this video, we'll cover buttons in SwiftUI from basics to styling, navigation, and animations. Hi, I'm Alish, founder of Bugfender, trusted by over 34,000 brands to fix bugs faster and build better apps. Let's start briefly with the basics. What is a SwiftUI button? Everyone should know what is a button, but you might not know that in SwiftUI a button is made up of several key components. The action is what happens when the button is pressed. Maybe it submits a form, navigates to another screen, or runs some code. The label is what the user sees and taps. It could be text, an icon, or even a custom view. Then we have styling, which controls the look, colors, shapes, and backgrounds. A role, like .destructive or .cancel, tells the system if a button is dangerous or dismissive. And finally, interactivity, which lets us enable or disable a button depending on app state. Put together, these components make SwiftUI buttons flexible and powerful. So how do we actually create a button in SwiftUI? Before we dive in, one quick note. All of these examples live inside a standard SwiftUI file. At the very top, we write import SwiftUI. That just gives us access to all the SwiftUI tools. Next, we have a structure called content view, just like our file name. Think of this as the screen we're building. Inside it, there's the body section. This is where we describe what should actually appear on that screen. And finally, at the bottom, there's a preview section. That tells Xcode to show this screen on the right side so we can instantly see changes as we code. This being said, we can just focus on the button code itself. First, we have the button keyword. Inside the parentheses, the first curly braces hold the action. In this case, it prints button clicked to the console when tapped. Then we have another set of curly braces, which define the label. Here I'm just showing some text that says button create example. So when I tap the button, you can see it prints button clicked right here in the console. Here are the typical actions you'll use inside a button. Update state. First, we add a state variable called isLoggedIn. This means the value belongs to the view, and when it changes, SwiftUI updates the UI. It starts as false. We mark it as private, so it can only be used inside this view. Here we stack views vertically with 16 points of spacing. This is our button with the label text submit. And the action flips our state. Toggle simply switches false to true, or true back to false. This line uses the ternary operator, the question mark and colon. If isLoggedIn is true, it shows logged in. If it's false, it shows logged out. Because it's tied to state, the text updates automatically when we tap the button. Next, we have navigation. Let's say we want a button that takes us to another screen. The first step is to wrap everything in a navigation stack. This creates a container that lets us move between screens. Inside it, we add a navigation link. The label is just the word submit, and when we tap it, SwiftUI automatically pushes us to the second screen. On our main screen, we also add a navigation title, so the title bar shows first at the top. It's not required, but it makes it clear which screen we're on. Now, what's inside second view? It's just another view with a text label that says welcome to the second screen. And just like before, we give this screen the navigation title second. Now, when we tap submit, SwiftUI takes us to the second screen. And in the top left, we see first. That back button label comes directly from the navigation title we set on the first view. The next common type of action is to call a function. In real apps, multiple buttons often do the same thing. Repeating the same code in every button leads to boilerplate and messy code. We can move the logic into a single function and call it when needed. If we ever need to reuse that logic or make changes later, we only update the function, not every button that uses it. Let's see a very simplified example. In the first version, each button repeats the same lines, so any change means updating multiple places. In the second, the shared logic lives in one function, making the code shorter, cleaner, and easier to maintain, especially as your buttons grow more complex. The fourth way we can use a button is to start background work. For example, imagine a button that fetches data from a server. When tapped, it shows loading. It waits 2 seconds, then updates to data loaded. We start with a state variable called message with the initial text no data yet. Then we put a button labeled submit. When tapped, it runs the code inside the braces. This starts an asynchronous task. It lets us run background work without blocking the interface. As soon as the button is tapped, we change the message to show feedback to the user. We pause for 2 seconds with task sleep to simulate slow work, like fetching data. The await means the task runs asynchronously. After the delay, we update the message again to show the result. This is a text view that always shows the current value of message. It updates automatically when the state changes. The last example of actions is logging, which records events to help with debugging, monitoring, analytics, and understanding user behavior. Here, 2 buttons call the same log action function, which uses print to log messages to the console. This keeps things simple while ensuring each action is recorded. We've seen the different actions a button can perform. Next, let's look at labels, how a button shows itself to the user. A button can be a simple text. In this case, we can even skip the action part and just write the label text directly inside the parentheses, followed by the action. Or we can use an image, more specifically, an icon from Apple's SF symbols library. SF stands for San Francisco, Apple's system font. The system name is basically the icon's ID, like trash or star.fill. If you don't know what icon to use or its system name, just ask ChatGPT or Gemini and they'll tell you which one to use. Then we have a label view, which combines text and image. And finally, custom views, giving you the flexibility to build unique buttons. You can use multiple icons or texts and stack them horizontally with an H stack or vertically with a V stack. Even without styling, you can already see the difference here. And that's it for labels. Now we know what buttons can do and the different ways they can show themselves. Next up is making them look right with styling. SwiftUI styling can be broken down in 5 categories. These categories let us match buttons to our brand and ensure they feel smooth and natural on every platform. SwiftUI includes built-in styles you can apply with button style. You can insert one of these style values and the system instantly changes how the button looks, adapting it automatically to the platform and appearance. Automatic uses the system default style. Plain removes all styling if you want to style it from scratch. Bordered adds an outline. Good for secondary buttons. Borderless is mainly for macOS. On iOS it looks like plain. Link is macOS only. It makes the button look like a text link. Next we have colors and backgrounds. We're adding padding in each button just so the background is visible. We'll cover it properly later. Use foreground style to set the text or icon color. Use background to fill behind the label with a solid color, a gradient, or even a brand color. The first button uses a simple solid fill with system colors. These are built in and stay consistent across Apple platforms. For gradients, SwiftUI gives us 3 options: linear, radial, and angular. Linear uses a start and end point. Radial expands from a center with start and end radius, and angular rotates colors around a center. Linear is usually the most common choice. We won't go deep into gradients here, just know you can mix start and end points in many ways to get different looks. In larger projects, it's easier to keep colors consistent by using named colors. Color brand primary looks for a color we should have added in the asset catalog beforehand. You can add as many as you want, like brand primary or brand secondary, and they'll update everywhere in the app automatically. This uses RGB decimals 0 to 1. If you have a hex code, convert it to these values. It's easy to do with a quick converter or by asking ChatGPT. Now let's move on to the next styling category: layout and spacing. Quick note before we start: layout and spacing aren't visible on a transparent button, so for this section we'll keep all buttons with a blue background and white text. So first option, we have the default padding. It uses the built-in spacing of SwiftUI. With horizontal and vertical padding, we set equal spacing between both left to right and top to bottom. These values are points, not pixels, so they scale across devices. Control size lets us resize buttons using system presets. We can pick mini, small, regular, or large, and the system adjusts padding and layout automatically while keeping the button native. With frame, we can tell the exact width and height we want for the button. Next, we have corner radius, which can round the edges with a radius to soften the look of the button. With clip shape, you can cut the button into different standard forms. Now we move on to typography. As we've already seen, without instruction, the button uses the default system font and size. With font, we can apply built-in text styles like large title, headline, or caption. They adapt automatically to accessibility. With font weight, we can change how thick or thin the text looks. SwiftUI gives us a full range, from ultralight all the way up to black. When it comes to fonts, SwiftUI defaults to San Francisco. We can switch to the system's monospaced design, which adapts automatically to size and accessibility. With custom, we can use pre-installed families like Courier New and also set the font size directly. And for brand fonts, we can reference them by name, but only after adding and registering the files correctly. That takes a few extra steps, so we won't go deeper in this video. Now let's talk about animations and effects. We'll start with scale on press effect. This state tracks if the button is in its pressed animation or not. When tapped, the first with animation shrinks the button in 0.18 seconds. Then after 0.18 delay, the second one grows it back. That's what makes the bounce effect. Scale effect makes the button shrink to 95% when pressed is true and return to normal when it's false, while with animation keeps it smooth. Now let's see shadow and glow to make a CTA feel lifted. Just like before, this state tracks if the button is pressed and with animation makes the change smooth. The first shadow is the drop shadow. It uses black at 25% opacity. When the variable lifted is true, the radius is 12 and the y offset is 12, so the shadow looks bigger and further down. When lifted is false, the radius is only 6 and the offset is 4, making it tighter and closer to the button. The second shadow adds a glow with black at 35% opacity this time. Its radius grows from 10 when not lifted up to 22 when lifted, so the glow expands and makes the button feel more active. Next, let's look at rotation, which is often used for frequently asked questions or refresh reload icons. We've already seen state variables with animation and the icon button using system name. The new part here is rotation effect, which rotates the chevron to 180 degrees when true and back to 0 when false. This is a realistic practical example of use case. Another one is the refresh or reload arrow. This time, instead of toggling a boolean, we use a number called angle. With animation this time adds 360 degrees to angle in 0.6 seconds. Then rotation effect takes this number and spins the arrow by that amount. Each tap makes the arrow do a full circle. We've simplified it here, but in real apps it usually keeps spinning until the reload finishes. So far we've covered the action, the label and styling. Now comes the role. It tells SwiftUI what a button does, so the system can style it automatically and make its purpose clear. The best use cases are confirmation dialogues and alerts, where the differences really stand out. The first state variable controls if the dialog should show or not. The second one looks at the status message, starting with ready. The button manage log opens the dialog message by setting the variable true. This creates a confirmation dialog that is presented if show actions is true and the small title log actions is always visible. Then we have three options. Destructive role is for actions that delete data or make irreversible changes. It's automatically in red to let the users know it's risky. None role means it's just a regular button. If you don't set anything, by default, the button has no role. And finally, the cancel role is for dismissing a screen or backing out of an operation. In alerts or dialogues, it appears in blue, making it clear it's the safe way out. The last piece to cover is interactivity. Buttons can be enabled or disabled. This is common in forms like login, where the button stays inactive until the required fields are filled. The state variables store username and password. We use a navigation stack to simulate moving to another page after login. There's a text field for the username and a secure field for the password, with some styling. The navigation link acts like a button. It stays inactive if the username or password are empty. And here's the page we navigate to after logging in. As you can see, continue stays inactive until both fields are filled. Once I enter a username and password, it becomes active. And when I tap it, it takes me to the next screen. Another example is an agree to terms toggle. The continue button stays inactive, and only if you agree can you proceed. Lastly, let's look at some common real-life SwiftUI button examples to recap what you've learned. First, we have an add to cart button. As actions, the first button calls the function add to cart and sets the variable show cart confirmation to true. The label combines text and an icon styled with basic system modifiers. The button triggers an alert with an OK button using the cancel role just to provide user feedback. The add to cart function just prints a message here, but in a real app, it would handle the actual logic. The second example is a simple delete button. It has a destructive role and sets off the alert message to ask for a second confirmation. Here we have another destructive button and a cancel button. The function is triggered once the second destructive button is tapped. Lastly, a favorite toggle button that changes the icon and color when tapped. The button's action calls toggle favorite, which flips the variable and prints a message based on its new state. This time we use the ternary operators for the icon and color, so the heart switches between filled red when favorite and gray outline when not. And that's it for this video. If you've enjoyed it, don't forget to like and subscribe. And if you want to debug smarter with remote logs, crash reports, and real-time error tracking, you can sign up for free at bugfender.com. Thanks for watching and see you in the next one.